Up some of the problems, and these are basically from your Selena, and these are from question 12 B part. The rest I had taken up, so let's do these. Here the question is that you have to verify this, and what do you have to verify? That this is equal to 1. So the answer has to come to 1, and I will start with this because this is the left hand side, this is the right hand side. So I will write left hand side is equal to this whole thing and remove this. The answer has to come to what? To 1. Alright, so I will write this like this. 1 upon, can I write this as x? Because I have x and x over here. I can write this as x raised to the power of 0 plus x raised to the power of minus b plus 1 upon 1 plus x raised to the power of b minus a. And here also I will remove this and write x raised to the power of 0, because x raised to the power of 0 is equal to 1. But here what I want to do is, I want to make it even more simpler. So I will write x raised to the power of a minus a. A minus a will also be 0, and here also, here I will write, because b is given here, x raised to the power of b minus b. Clear? And now let's look at this. Can I just write this as, if I have something like this, what does it actually mean? This actually means that I can split them. What do I mean by split? I can write this as x raised to the power of a into x raised to the power of minus a. You remember your power law? X raised to the power of a into x raised to the power of minus a will be equal to x raised to the power of a plus minus a, which will make it x raised to the power of a minus a. So that is what I have done over here. And then, so here I have this, and here I can write x raised to the power of a into x raised to the power of minus b, and then plus and 1 upon, similarly, I am going to split this. This is my product law in the reverse. X raised to the power of b into x raised to the power of minus b plus x raised to the power of b into x raised to the power of minus a. If this much is clear, then can I do this? Can I take a as common? If I take a as common, what will happen? It will become x raised to the power of a in bracket x raised to the power of minus a plus x raised to the power of minus b. And then I have the plus here, and here I take x raised to the power of b as common. So this becomes x raised to the power of b and x raised to the power of minus b plus x raised to the power of minus a. And of course, whether I write this side or this side, it makes no difference. So I am writing this here, ulta, just for making it more convenient, because minus a and minus b, and this is also minus a and minus b, like you can see. Now here, can I just write this as 1 upon x raised to the power of a into 1 upon x raised to the power of minus a plus x raised to the power of minus b. This whole thing here. This multiplied by this, like this. So this is being separated. Here, 1 upon x raised to the power of b multiplied by 1 upon x raised to the power of minus a plus x raised to the power of minus b. I am putting it in brackets just so that you don't make any mistakes over here. Now here, can I say that this one is common? This one? So this whole thing is common. There is a plus here in between. So I will remove this and take it as common. 1 upon x raised to the power of minus a plus x raised to the power of minus b. And I put this in one bracket, and here what is left is 1 upon x raised to the power of a plus 1 upon x raised to the power of b, and bracket closed. Is that clear? If this is clear, then can I also do the reverse over here? If I do the reverse, what happens? How will I write this? Let's see this. So here what I am doing is, I am leaving this like this, put this in bracket here, and this one is in the other bracket, and I can write this as x raised to the power of minus a plus x raised to the power of minus b. Is that clear till here? And after that, I can put it all together. I can write this because this is multiply. So I'll write this as x raised to the power of minus a plus x raised to the power of minus b upon this bit. Can you see this? Yes. So I write this one here. This whole thing is same as this whole thing. If there is a plus, I will have to consider the whole thing. So this whole thing gets cancelled and this answer becomes 1. So I write is equal to 1 and then I write right hand side. And after that I will write hence proved. You must write hence proved. Is that clear? I hope this is very clear. Alright, now I'm going to just copy down the next one and then show you the solution of that one. Alright, so this is question 13a part and it is 12 raised to the power of minus 5. I hope I've copied it correctly. 12 raised to the power of 2n plus 1 is equal to 12 raised to the power of 13 divided by 12 raised to the power of 7, and you have to find the value of n. I don't need to do anything to these 12 because all of them are 12. That means the bases are all the same. So what I'm going to do is I need to leave only this, and I've told you again and again that this thing of cross multiplying, I don't believe in doing it that way. It's better to understand what you're doing. So I can say that I have to remove this 12 raised to the power of minus 5. So let me write 12 raised to the power of minus 5, but it's an equal to. So that means the balance has to be there. So this whole thing has to be divided by 12 raised to the power of minus 5 here also. So this gets cancelled out. And what is left here is 12 raised to the power of 2n plus 1. Right? And here, can I write this as 12, because this is divided, it means 13 minus 7 upon 12 raised to the power of minus 5. And therefore, I can write this as 12 raised to the power of 2n plus 1 is equal to 12 raised to the power of 13 minus 7 is how much? 6. Upon 12 raised to the power of minus 5. Can I just take this and make it 12 raised to the power of 5 reciprocal, and then I do 12 raised to the power of 2n plus 1 is equal to 12 raised to the power of 6 plus 5. This means 12 raised to the power of 2n plus 1 is equal to 12 raised to the power of 11, and therefore I put the therefore sign and I write 2n plus 1 is equal to 11, right? And again, I would suggest don't do this, take it that side and take it this side. This is plus 1, I need to keep only n here. So first thing I do is minus 1 and minus 1. So plus 1 minus 1 is 0. And here 11 minus 1 becomes 10 is equal to 2n. Now I divide this by 2, so this becomes n only. And I divide this also by 2 because it's an equal to sign. I have to do it, do the same thing on both sides of the equal to sign. So 2 ones are 2 and 2 ones are 2. So 2 ones are 2 and 2 fives are 10. So the value of n is equal to 5. I hope this is clear. I'm going to the next sum. Let me copy it down before you see it. Alright. So this is the next part of question 13. Now here, let me see what I'm going to do here. In this one, I'm not going to do anything right now because I have this a square. Let me sort it out first. So this becomes, I'll write or because this is an equal to over here. I have to calculate the value of n. And therefore, this becomes a raised to the power of 2n minus 3 into a raised to the power of the power law. This 2 will be multiplied by this whole n plus 1. So I write it like this. Upon a raised to the power of 4 into minus 3 is equal to a raised to the power of 3 into 3 divided by a raised to the power of 6 into minus 3. I hope this is clear. And then this will be or this will be written as, and I'm going to only write this. This I'm going to take that side because it does not have n. So I can't really do anything much here. But here what I'll do is, I will add this. This is now my product law, right? That means the powers will be added. So 2n minus 3 plus 2 into n plus 1. We'll sort this out in a little while. Upon a raised to the power of minus 4 3s are 12, because the sign is plus and minus, so plus into minus is minus, is equal to a raised to the power of 3 3s are 9 divided by a raised to the power of 6 3s are 18, plus into minus is minus. Is that clear? Alright, now let's look at this. This can be written as a raised to the power of 2n minus 3 plus, I open this. So I multiply by 2. So plus, there is a plus outside, so whatever sign is inside, that is going to be written. So this becomes 2n, and 2 1s are 2 plus 2. And this side, I'm going to take this there, so that's why I haven't done anything here. So this will become a raised to the power of 9 upon a raised to the power of minus 18. Or let me just, take this here into a raised to the power of minus 12. This actually means that I have multiplied this by a raised to the power of minus 12. This gets cancelled over here. Did you understand what I said? This is a raised to the power of minus 12. So if I multiply this whole thing by a raised to the power of minus 12 here, and I multiply this by a raised to the power of minus 12, it will remain like this, but here it will get cancelled. A raised to the power of minus 12 divided by a raised to the power of minus 12. So this here now becomes 2n plus 2n is 4n, and minus 3 plus 2. One is plus and the other is minus. So I subtract, and the sign will be of the larger digit. So minus 1 is equal to, this is going to be now a raised to the power of 9. This will be the reciprocal here, and this will go down the reciprocal, and sign will become positive. So this is now a raised to the power of 4n minus 1 is equal to a raised to the power of 9 plus 18 minus 12, right? This 12. So what does it become? Let me write it properly. It's not written neatly. So I'm just writing this here. A raised to the power of 9 plus 18 and minus 12. So what does it become? Or a is equal to 4n minus 1 is equal to a raised to the power of 9 plus 18. That is 27. And 27 minus 12. How much is that? 15. Right? So now what do? I'm rubbing this out so that you can understand what I'm doing. And I'll make the therefore sign. And I will take the powers. Because the bases are same. So 4n minus 1 is equal to 15. And therefore, again, I won't do, take this that side. No, I'm doing plus 1 and plus 1. It's an equal to sign. So this becomes 4n, and here I have managed to remove this. Plus 1 minus 1 is 0. So this is equal to 16. And then I do divide by 4. This becomes n and this becomes 4. So the value of n is 4. So this is question number 14, and this is the first part. I hope I have copied it correctly. No, this is 2n plus 3. If it's wrong, we'll see. Is equal to a raised to the power of 2n plus 3 and into a, let's open this bracket, 2n multiplied by this. This means plus 2n, this is plus n. So 2n into n will be 2n square, plus into plus is plus, 2 2s are 4n, plus into plus is plus, 1 into n is 1n, plus into plus is plus, and 1 2s are 2 upon this. Can I write this as a raised to the power of 3 into 2n plus 1. I don't like to skip steps, but because of the board, I am writing this here. So this becomes 3 into 2n plus 1. So this becomes 3 2s are 6n plus 3 into 1 is 3. So I leave this like this. Then I write a raised to the power of n into 2n is 2n square, and n into 1 will be plus n, right? So I can write this as a raised to the power of 2n plus 3 into a raised to the power of 2n square plus 5n plus 2 upon, I'll do it in the next step, I could have done it here also, a raised to the power of 6n plus 3 into a raised to the power of 2n square plus n, right? Then I write again product law, and then I'll go reverse of product law. I will add these and then I will split this. So 2n square, first I'll write the highest power, so 2n square, and you can write all of them together. In fact, first let's just write all of them together, don't want you to get confused, plus 2n square plus 5n plus 2 upon a raised to the power of 6n plus 3 plus 2n square plus n. I hope you've understood what I've done here, and then after that I will add up all the powers, and this will become this one. I'll write this one. Keep underlining with a pencil. You won't make a mistake then. 2n square plus 7n. I'm leaving this plus 3 and plus 2. I'll tell you why. Because I have a plus 3 here and a plus 3 here. But I have a plus 2 here only and I don't have a plus 2 here. So I write this as plus 3 and plus 2. You'll just understand why I did that. And here I have 2n square plus 6n plus 1n is 7n and plus 3, like I told you, right? I'm going to copy this here so that you can understand it more clearly. Look at what I'm doing. I'm copying this part here. A raised to the power of 2n square plus 7n plus 3 plus 2. And what do I have here? A raised to the power of 2n square plus 7n plus 3, right? So what I'm going to do now is I am going to split, meaning I'll do the reverse of the product law that I was doing. I write, this is common, so I'll keep this same. I write a raised to the power of 2n square plus 7n plus 3 into a raised to the power of 2 upon a raised to the power of 2n square plus 7n plus 3. You'll ask me why I did this. You know very well. Look at this. X raised to the power of a into x raised to the power of b is written as x raised to the power of a plus b, right? This is how it is, this plus 2. So I can do the reverse, meaning if I have x raised to the power of a plus b, I can write it as x raised to the power of a into x raised to the power of b. That is what I have done here. Clear? Alright, so if you have, for example, 2a square upon 2, don't we do 2 ones are 2 ones are? So if this whole thing, this is actually a raised to the power of 2. It could be, this means I could also write this as x square a square upon x square. What will happen here? I will cancel these two, right? So if I have this same thing over here, base is the same, power is the same, I can cancel this over here and my answer will become a square. I hope this one is clear. I'm going on to the next one. Alright, so this is the last sum in exercise 2a. Let's see how this is to be done. This is going to be written as equal to x raised to the power of, what will I write? I am going to first open this one, and can I open this directly like I told you earlier also? So I'll write 2n plus 7 into x raised to the power of, this actually means this, right, upon x raised to the power of, I'll open this, 4 2s are 8n plus into plus is plus, 4 3s are 12, right? And then I can write x raised to the power of 2n plus 7 into x raised to the power of plus 2 into 3 plus 3n is plus 6n plus into plus is plus 4 upon x raised to the power of 8n plus 12. So I'm going to combine your both your product law and then your quotient law. First is the product law. 2n plus 7 plus 6n plus 4. Because all of them are plus, so there's no problem. Upon x raised to the power of 18 plus 12. And then can I solve this? this will become, can you see this here? Yes. Let me write this here. So this will become x, 6n plus 2n is equal to 8n, and 7 plus 4 is 11. So plus 11, right? And then you have this. So this I will copy just like it is. So it becomes upon x raised to the power of 8n plus 12. Now you have plus 11 and you have plus 12 over here. Now how can we solve this? Quotient law. Alright. So you have, I'm writing this here, but you must write it one under the other. This becomes x raised to the power of 8n plus 11, and then this whole thing is minus. So I'm writing the minus outside and putting the whole thing in brackets. 8n plus 12. This is where you tend to make a mistake. Alright, when you have more than one number, then you should put it together. And this will become x raised to the power of 8n plus 11 minus 8n, and see, minus 12. So you have to be careful with this bit. So 8n minus 8n is 0, and 11 minus 12 will be minus 1. Get that? Alright, so this becomes equal to, I'm writing it here, but please try to write it one under the other. Alright, so x raised to the power of minus 1, which can be written as 1 upon x. And with that, we come to the end of all the problems in exercise 2a. I hope you're able to do them properly. Yeah, this is 1 by x, right? So I'm going to start with the next chapter after this. All right, enjoy yourself. Bye.